So here's where we're going to start. We're going to start with right where we left off last time in section 6.2. So this is a problem just like something we have already done. It's no different. So please do this. So this is section 6.2. We're talking about adding and subtracting rational expressions. And so I would like you to do this. This is how we ended our time together last time. So you've got negative 3x plus 7 over x squared plus 7x plus 12. And I want you to add to that 8x plus 13 over x squared plus 7x plus 12. Okay, so I'm going to give you a couple minutes to add that and then simplify anything you get. It has common denominator because that's where we left off. And then we've got our new stuff for the day. Okay, so these two already have common denominator. So remind me, and again, this is where we left off last time. What's my process with my fractions when they have the common denominator? Add straight across on the top, and then we leave the bottom alone. So I'm going to add straight across. I've got some like terms. I've got a negative 3x plus an 8x, so that becomes 5x. I've got 7 plus 13, that becomes 20. The denominator, you leave alone. Once it's common, you have nothing else to do with that, so that is x squared plus 7x plus 12. So if you did that, you did the adding correctly, and that's great. From there, we need to reduce this. That was the other thing we talked about last time. So this problem here incorporates pretty much everything we talked about last class. So in the numerator, how can I factor the numerator? What can I do? Take out the 5. Yes, sir. Thank you very much. So I'm going to take out the 5. 5x, I take out the 5, leaves x. 20, factor out the 5, leaves plus 4. In the denominator, I've got a trinomial, a 1 in front of the squared, so that's great news. X squared is x and x. This tells me my signs have to be the same. This tells me they're both positive. And then the two factors of 12 that are going to add up to 7 are 4 and 3 in no particular order, 4, 3, and 4. Last step, I'm going to cancel out those things that are in common. And I have 5 over x plus 3. So that's where we left off last time. We added fractions, and then we simplified them. So now that takes us into our present moment, where we are going to do this problem. So I've got 7 over x plus 4, and I want to add to that 11 over x minus 5. Okay, so I've got two fractions, but now the denominators are different. So what I need to do is I need to find the common denominator. Okay, that's the challenge to this problem, is finding it. In fact, we're going to start, if not finish, the next section in this class, because it's not super long. We're going to use the common denominator there. So today is Common Denominator Day in algebra class. So let me just give you I'm just going to try to make this as simple as possible, to summarize it as cleanly as possible. To find the common denominator, here's what you do. Okay. You need one of every factor you see. You need one of every factor. And then if you have powers, you take the highest power of that factor. Okay, if there's powers, you take the highest power. So when you find the common denominator, you need one of every single factor you see. And if there happens to be powers, then you need powers, the highest power of that factor. Okay, so we're going to go through several examples that help us get used to doing that. So write that down, keep that in your notes, put a circle around it. That's super important for the next 3 sections of the book. Being able to find the common denominator is going to lead you to succeed in a lot of things. So for this problem right here, I have 7 over x plus 4, and I have 11 over x plus 5. So what I want to know is, what is the common denominator of this? What do I need? So tell me a factor that I need in my common denominator. Okay, well, 1 is going to be there because 1 times anything is just the thing. So one is part of everything. So I don't necessarily need a 1 per se. Okay, I need an x in some form, but I don't just have a plain old x here. Remember, when we have our numerators and denominators, terms go together. So if things are being added and subtracted together, they can't just be plucked apart. Okay, so I'm going to need an x, but I don't just have a plain x. What's the first denominator? X plus 4. There you go. There's your first factor you need. You need an x plus 4. You need both of those things. Okay, that is the first denominator. That's the first factor that you need in your common denominator. What other factor do we see in a denominator? Yeah, now once we do a couple of these, you'll catch on. This x plus 4, remember, because it's plus, because they're being added, that's all one thing. You can't just separate it. Because this is x minus 5, that's all one thing. I know you want to say, oh, we've got an x in both of them, so that's common, but the x doesn't exist by itself. That's the problem. Okay, so if I'm going to take this x, I have to take the plus 4. There's my x plus 4, and then that is x minus 5. There's no third factor. Those are the only 2 denominators. Those are the only 2 factors. So that's my common denominator for this problem right there. X plus 4, x minus 5. So step 1, find your common denominator. Here's step 2. What I now need to do is I need to change these fractions into fractions that have that as the denominator. So this is the process I use. This is what I'm going to show you. If you don't have a process, then I would invite you to do this, because we want to do the same thing every time so that we can remember it. So what I'm going to do is I'm going to take this common denominator. I've got 2 fractions. I'm going to write that common denominator twice. So I've got x plus 4, x minus 5. That's going to be for this fraction. Plus, I've got x plus 4, x minus 5. That's going to be for this fraction. I wrote my common denominator down twice, once for each of the 2 fractions that I have. Everybody caught up with me? You okay? Give me another moment. I see some of you still writing. I don't want to lose anybody on this first example because these are the key steps. So first thing I did, I found the common denominator. Second thing I did, I took that common denominator and I wrote it once for each of my fractions. This tells me what I have to change the fraction into. So now, step 3, I need to now change the numerator accordingly. I've changed the denominator of each fraction, so that means the numerator has to change. I can't just write 7 here, can't just write 11 here. That would be wrong. So here's how we figure out what to do. What did I do to change this denominator? It's not just x plus 4. What did I add on to it? Yeah, what did I multiply by to get from here, where I started, to here, the common denominator? What changed? What did I multiply by? That's true. Okay, so what I'm going to do here is x minus 5. And remember, when you do something to the denominator of a fraction, I multiplied this denominator by x minus 5. I got to do the same thing to the numerator, x minus 5. So now it tells me what my new numerator is. I'm going to distribute 7 times x is 7x. 7 times negative 5 is negative 35. So do me this favor. Okay, I just showed you. This is what we started with. This is what we want to go to, the common denominator. And so in this case, I had to multiply the x plus 4 times x minus 5. That's what makes that match. So that tells me that's where I had to do the numerator. Do the same thing for the other fraction. Figure out what is the new numerator when you make this, which started out as x minus 5, into this, the common denominator. So what do I need to multiply this denominator by to make it into this right here? Yep, it's missing the x plus 4. So since I did that, I have to multiply the top by the same thing. When you're working with a fraction, if you multiply the bottom of a fraction by something, you have to multiply the top by the same thing. And so now when I do that, I have 11 times x is 11x. 11 times 4 is 44. At this point now, I have both fractions. They have the common denominator. We are where we ended up at the end of last class, adding fractions with a common denominator. So hopefully this looks kind of familiar because from here on out, this should not be new. I hope you did your homework and got caught up in the 5 days since we've seen each other. Okay, so the new part of this is changing our fractions that didn't have a common denominator into fractions that now do have a common denominator. The rest of this, 7x plus 11x, that's 18x. Negative 35 plus 44, that is what, positive 9, I think. And then in the bottom, I have x plus 4 times x minus 5. I'm not going to multiply that. Don't do any extra work than you need to. I could factor out a 9 out of the top, but I'm just looking ahead. If I factor out a 9 out of the top, I'm going to have a 2x here. And I don't have anything with a 2x in the denominator, so nothing's going to cancel. There's no reason to do that. I'm done with the problem. I know this is difficult. Okay, I understand. We don't like fractions. We're automatically, as soon as you say the word fraction, our heart rate starts to go up, blood pressure. So we're going to do a few of these to walk through the process. Let me just remind you one more time what we did. The first thing we did with the problem is we found what the common denominator was. Then we wrote that common denominator for each fraction. I only had 2 this time. Then I said, okay, what did I have to do to the original fraction to make it match the common denominator? So this one I had to multiply the original fraction by x minus 5 to make it match. This one I had to multiply the original fraction by x plus 4 to make it match. And then I do the same thing to the tops and add them up. So difficult process. Here is a problem for you. It is shockingly similar to the problem that I just did, just some different numbers. So you get to go through the process. So here we go. 3 over y plus 2. And then we're going to add to that 4 over y minus 3. And what I would like you to do, write that down. And then I want you to write down what you think the common denominator is and then stop so that we're all work the problem together. So write down what you think the common denominator is and then go ahead and stop. Okay, if my first fraction is 3 over y plus 2, and my second fraction is 4 over y minus 3, what is the common denominator? Y minus 3? And times y plus 2. Basically, it's just one of every factor you see, and that's what I said. You need one of every factor that you see, every different denominator, and then if there's a power, you take the highest power. Now, there's no powers here, so I don't have to worry about that. We'll get to a situation where we have to do that. Okay, so now I'm going to let you do the rest of the problem. You're going to take that common denominator. You're going to write it once for each of the two fractions. Then you're going to change the numerators, okay, to match the change in the denominator. All right, so we're going to run through this process. I'm going to give you another problem. We're going to run through the process again. Okay, so here's the original problem. Here are the two denominators. So from that, if I'm going to have a common denominator, it has to have a y plus 2, and it has to have a y minus 3. So that's why those are the two factors over here. So now I took that common denominator and I wrote it once for each fraction. If you had 3 fractions, you would write it 3 times. Okay, so this is 1 time for each fraction. Now, what did we multiply by here to make this denominator that I started with look like this? True? So that's what I have to do to the numerator. I have to multiply by y minus 3. So 3 times y is 3y. 3 times negative 3 is negative 9. Over here, what did I have to multiply this denominator by to make it look like this denominator, the common denominator? True. All right, I'm hearing more people. Love it. So 4 times y is 4y, 4 times 2 is plus 8. Okay, that's difficult. That's the new information for the day for adding and subtracting fractions. Okay, so that takes a lot of effort. We're going to practice it again in just a minute. Now I'll add 3y plus 4y, that is 7y. Negative 9 plus 8 is negative 1. Nothing in common there. I can't factor that at all, so I'm just about done with the problem. My denominator is y minus 3 over y plus 2. There is no value to you to multiply that out. It's just extra work that you don't need to do. So leave the denominator just like that. We're done. Here's another one. Okay, so I would like you to do this. It's going to be the same process. This time it's going to be subtraction. Okay, so it's just a subtraction problem this time, but it doesn't change really anything. So I've got 5 over x plus 4 minus 2 over x minus 6. So what I'm going to do is give you 60 seconds after you've written down the problem. I would like you to identify what you think the least common denominator is. All right, what is your least common denominator? Tell me one of the factors I need. X plus 4, yes, great. What's another factor I need? X minus 6, there are no other factors in this problem. There's only those two. So there we go. So now what you're going to do is finish out the process. You're going to take that. You're going to write it once for each fraction. And then you're going to do, what do you have to do to change the numerators? One word of caution, this minus, when we're subtracting, we treat it like a negative. So when I distribute, like we did over there, you're distributing a negative 2 now, not a positive 2. Okay, so just keep that in mind as you do the problem. If you make a mistake, that's okay. We'll fix it. So the first fraction starts out as just x plus 4. I am changing it into this, so that means I have to multiply by an x minus 6. And when I do that, my numerator becomes 5 times x, or 5x. 5 times negative 6, negative 30. Over here, I started out with an x minus 6. I have to turn it into this, so that means I have to multiply by an x plus 4. And the word of advice that I gave you was, since this is a subtraction, I have to account for that negative. So what I'm going to do is I'm going to multiply negative 2 times each of these. So negative 2 times x is negative 2x. Negative 2 times 4 is negative 8. And now I can go ahead and add up my numerators. So when I do that, 5x and negative 2x is 3. Negative 30 and negative 8 is negative 38. Nothing factors out of that. There's no common factor, so this problem is almost done. There's my result. I've got one more of this style problem, and then I'm going to show you a slightly different denominator, and we're going to talk about the common denominator. It doesn't violate anything that we've done or my practical advice of one of each factor, and then if you have powers, you take the highest power. So here is the next problem that you're going to have help me along with here. This is 4 over x squared minus 2x minus 3. And to that, we are going to add 3 over x squared minus 5x plus 6. On this problem, before I can identify the common denominator, I need to do something to each of these denominators first, so I can see what the factors are. So since they're trinomials, that might spark a memory. What do you think I'm going to have to do as a first step to each of these two denominators? Somebody said it. Factor them. Yes, I need to know what the factors are, so I have to split these up. So what I would like you to do, I'm going to give you a minute and a half to do this. I'm just going to write it just right below each of these. I would like you to factor the first denominator and factor the second denominator and then stop. None of the other ones we've done, we've had to factor. This is the first time. It's going to happen once in a while. Factor your denominators. All right, so I'm going to go ahead and factor both of these. So this one, both of these situations, we've got a 1 in front of the x squared. So x squared here is x and x. The negative in front of the 3 tells me that my signs got to be different. So I've got a positive and a negative. And the two factors of 3, in fact, the only factors of 3 are 3 and 1. So the 1's going to be positive, the 3 is going to be negative because they have to add up to a negative 2. Over here, x squared is x and x. This tells me my signs have to be the same. And since they have to be the same, this tells me they both have to be negative. They have to add up to a negative 5. And so the two factors of 6 that add up to negative 5 are negative 3 and negative 2. There's my two denominators completely factored. I'm just going to cross through the originals because I factored them. So I'm now going to work with these. So here's what I would like you to do. Okay, this is the challenge. I know this is slightly different. I want you to write down what you hypothesize the least common denominator is. I'm going to give you 45 seconds to do that. What is the least common denominator? And remember my instruction to you. The least common denominator is 1 of every factor you see. And if there's powers, you take the highest power. Okay, so tell me, if I am compiling the least common denominator and I take one of everything I see, what's the first factor I need in my least common denominator? Sure. What's another factor I need in my common denominator? You said both of them, x minus 2, x minus 3. In no particular order. If yours are in a different order, that's fine. You just need these three factors because that's the three factors I have over here. Now you might be saying, hey, Perkster, the x minus 3 is in both. Do I need two of them over here? The only time you need more than one is if there was a power. Do either of these x minus 3's have a power of 2? So there's only one of them here. There's only one of them here. So you only need one of them over here. So no, you do not need to have x minus 3 squared. So now what you're going to do, just like we did before, and I'm going to let you finish this up, you're going to take the common denominator. You're going to write it for each fraction. And now you're going to say, okay, what do I have to do to the numerator now to account for the change in my denominator? So I'm going to give you a minute or two to go ahead and make some progress on that. All right, so what factor has changed from this denominator to this denominator? What's the new one? The x minus 2. So I need to multiply here by x minus 2. That's what makes this the same as the common denominator. So 4 times x is 4x. 4 times negative 2 is negative 8. What had to change from here to get to the common denominator? What did you do? X plus 1. So notice we are doing the same thing every time. Yeah, this is a difficult process. I totally understand. That's why I'm trying to lead you through the exact same steps every time. Step 1, what's the common denominator? Step 2, write it for each fraction. Step 3, figure out what's missing and multiply the numerator by it. So that now 3x, 3. Step 4, the last step, is I can actually do the adding or the subtracting, whatever it is. So 4x plus 3x is 7x. Negative 8 plus 3 is negative 5. Nothing factors out of that, so I'm not going to be able to simplify this at all. So I have x plus 1, x minus 2, x minus 3. And there we go. Again, there is absolutely no need in the world to multiply anything on the bottom. That would just be busy work, and we have enough busy work going on. Okay, we're going to do one more problem like this, and then we're going to go on to the other style. We've got time, and I don't want to shortchange this topic. So here is this one. It's another subtraction. We've got 2x over x plus 4 minus 3x over x minus 7. So one more time, when you are done writing the problem down, I would like you to please identify the common denominator, and then we'll work forward from there. All right, so what is the least common denominator? What did you hypothesize that's going to be? X plus 4 and x minus 7. Okay, one of every factor you see. And now that you have that, go ahead and finish up the problem. All right, so on the first fraction, the difference between the denominator I started with and the common denominator is x minus 7. So I'm going to pop that in up here. So 2x times x. Notice this time what's different on this problem than previous ones is I've got an x here. Doesn't change the process at all. So 2x times x is 2x squared. 2x times negative 7 is negative 14x. And then over here, what's different from this denominator to the common one is the x plus 4. So negative 3x times x is negative 3x squared, and negative 3x times 4 is negative 12x. Now I'll finish up by going ahead and adding those things together. So 2x squared negative 3x squared is negative 1x squared. Negative 14 minus 12 is negative 26x over x plus 4, x minus 7. I can factor an x out of the top, and if you want to, that's fine, but that's going to leave me with a negative x minus 26. Nothing's going to cancel, so there's no reason to do it. Don't do any extra work that you don't need to do. Okay, the work that we need to do is enough work. All right, a couple more adding problems, and then we're going to be done with this section, and you're going to practice, because practice will lead to remembering, and that's what ultimately will want to happen here. All right, so here's another problem. It's going to be the same process, but this one looks a little different. So I've got 2 over 3x squared, and then plus 7 over 4x cubed. Now, the difference here that I have is instead of having binomials as my denominator, like we've had over here, x plus 4, x minus 7, things like that, I've got 2 monomials. I've got things being multiplied together. Okay, so I can see the factors here. So we're going to figure out together the least common denominator on this problem. Now, for the first time, we have a number. Now, again, there's no adding or no subtracting in the bottom, so I can think about these things separately. Just to reiterate, the reason that I can't just take the 4 or just take the x over here is because these are linked together with a plus sign. They go together. You can't just have one or the other. There is no plus or minus. These things are being multiplied, so I can think about them separately. So I'm going to first forget the x's for the minute. I've got a 3 and I got a 4. Does anyone remember what the common multiple between 3 and 4 is? What's the lowest common multiple they have? 2 would be a factor of 4, but 2 is not a factor of 3. Let me remind you how to do this. Not 1. Okay, we're going to go the other way. You guys are going smaller. We're going to go larger. So, just a sec. Well, in case you don't remember how to do this, here is the quickest and cleanest way to find a common multiple between 2 numbers. This is called the listing method. I like it because you can use your calculator and it's always going to work every time. What you do is you're going to take the 2 numbers, you're trying to find the multiple, or if there's 3 numbers or there's 9 numbers. There's only 2 here. So I'm going to start with 3, I'm going to start with 4. And all I'm going to do is I'm going to list the multiples until I find the one they have in common. So what I mean by that is 3 times 1. 3 times 1 is 3. 3 times 2. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. I can always add more on. I'm going to stop there. And if I need to, I can always add more multiples on. The multiples of 4. 4 times 1 is 4. 4 times 2 is 8, and I'm just looking now for when do they have one that's the same. 4 times 3 is 12. Oh, look at that. That's the least common multiple, the least common denominator, right there, 12. Aside from the numbers, aside from the 4 and the 3, what's the other factor you see that's in both of those denominators? Not the power, but what's the power on top of? X, yes, so I need an x. What did I tell you about your common denominator when you have powers? What do I always take? The highest. Which one's the highest power, x squared or x to the third? Third. There's common denominator. We did the coefficient, just like we did number fractions from arithmetic in middle school. Okay, so that we figured that out by the listing method. Okay, if you don't remember finding common denominators, I have some videos from classes I've taught. I can share them with you, and you can get yourself caught up. Okay, but the listing method will work for pretty much anything you're going to see in this class. And then the x, and you need the highest power. So just like we did before, now that I have that common denominator, I'm going to write it down once for each fraction. And I'm going to ask myself the same question. So I started off with 3x squared. I need to make it into 12x to the third. What do you need to multiply 3x squared by to make it into 12x to the third? 4 times 3 gives me the 12. And then x times the 2 x's that are already there gives me x to the third. So yes, indeed, 4x. That's great. Like I've said before, whatever you multiply the bottom by, you have to multiply the top by of a fraction. You can't just change it. So 4x times 2 is 8x. This denominator started out as 4x cubed. The common denominator that I have to change it into is 12x cubed. So what do I multiply up here to make this into 12x cubed? 7 times 3 is going to be 21. Once we're done with that, we're just about done with the problem. We saw a problem very similar to this last time when we were together. I've got the common denominator. I've got 2 things in the numerator. Neither of these things are like terms. So I'm just going to write it as 8x plus 21 over 12x to the third. Nothing factors out of the top. 8 is an even number. 21 is an odd number. So they don't have a 2 or anything. We're done. There's no simplifying I can do. That is it. Here's your second to last problem of this section. I would like you to please, this one's a subtraction, doesn't change anything about the problem. I would like you to please do this subtraction problem. Let's say that you have 9 over 5x squared minus 6 over, no, sorry, not a 6. I can't read my own writing here. A 4 over 6x to the fourth. All right, so I'm just going to give us a nudge of what the common denominator is, and I'll give you a little more time. So looking at this, forget about the x's for a moment. What's the common multiple between 6 and 5? 30. You can get that by the listing method, among other methods. And then how many x's do I need in my common denominator? 4. All right, keep going with the problem. Finish it out. 30x to the 4th is the common denominator. All right, so what do I need to do to the 5x squared to make it into 30x to the 4th? What needs to be multiplied by there? Six times 5 is 30. X squared times x squared is x to the fourth. Great. So 6 times 9 is 54 x squared. And then over here, what do I have to multiply the 6x squared by to make it 30x to the fourth? On this one, I don't need any x's because it already has 4 x's, and that's how many are in the common denominator. Okay, in the common denominator, you always take the highest power. You don't need all of them. You take whichever one's most. Okay, so I've already got the x to the fourth, but I do need the 5. That was great. So 4 times 5 is 20. So when I go ahead now, this is a subtraction problem. So I have 54x squared minus 20. Those are not like terms, so I won't add them, over 30x to the fourth. There is one little thing for the first time in all these problems, one little thing that I can do on this one. Both of these numbers are even, so I can factor out a 2 out of the top. 2 goes into 54 27 times. 2 goes into 20 10 times. And now I can cancel. Okay, we talked about this. This was the subject of section 6.1 that we did all of last time. 2 goes into 2 once, 2 goes into 30 15 times. So my reduced answer is going to be 27x squared minus 10 in the top, and it's going to be 15x to the fourth in the bottom. And that's my reduced fraction answer. One more question for this section. One more problem. It's the same thing we've just done. Only difference this time is there's going to be 2 variables. Remember, you take one of every factor you see, and when there's powers, you take the highest power. None of that changes, so you can take that to the bank on this problem. And here's what you're going to do for me. You're going to do 5 over 12 x to the fifth y squared minus 3 over 8x to the fourth y to the third. So I'm going to give you a moment to see how much of the common denominator you can sort out, and then I will help you. Okay, so my least common denominator. First, what's the common multiple between 12 and 8? When you list them out, what's the first number you come to? 24. What's the next factor I see? I need x. And how many do I need, Kyle? That's perfect. Excellent job. And then I have this one, I have another one. I need a y. How many y's do I need on this one? When you have powers, you take the highest power. And you need one of every factor you see. So we did our coefficient, we did our x's, we did our y's. You need one of every factor that you see, and then when there's powers, you take the highest power. So I'm going to give you a couple minutes to finish up this problem. You're almost done with it. All right, so the first fraction here, I've got to multiply the 12 by 2 to make it into 24. I've got 5 x's, the common denominator is 5, so I don't need any more x's. I've got y squared, I need to make it y third, so we need 1y. So 2 times y. And then 2y times 5, that's 10y. That's my first fraction. Then over here, I need to multiply the 8 by 3 to make it 24. I've got 4 x's, I need 5, so I multiply by an x. I've got 3 y's, I need 3 y's, so I don't need any more y's. It's already got the amount I need. So times 3x. So 3x times 3x is 9x. We're ready to subtract. So the top, these are not like terms, so don't try to combine them. That's doing some extra work, and it's also doing wrong work, so don't do it. 10y minus 9x. The denominator is 24x to the 5th, y to the 3rd, and I'm done. There's nothing factors out of the top. Remember, I haven't mentioned this today. I mentioned it like 57 times last time. I can't just say, oh, 2 goes into 10 and 2 goes into 24, because this 10y is attached to the 9x. You can't just take bits and pieces of terms. Done.